Okay, this is the same formula, but it applies to not only this one. What about this guy? Do we see a formula on our formula sheet for triangular prism? Do you see one there, Bryce, anywhere? Yeah? What is it? He's saying the answer before he even had a look. No, there's no picture here for a triangular prism. So here it is, general right prism. Okay? There's no picture, but that's the one we use. What does it say for the area there? Oh, it says area of base times height, the exact same thing. That's the same formula, okay? But now, for this base, that's not a rectangle, that's a triangle, right? And what's our formula for the area of a triangle? 1/2 base times height. I'm sorry we have the word base twice here because we got two bases, but that's just how it is, okay? There's 100,000 common English words, and we have to use the same one here to do math. Sorry, that's how it is, okay? So once you know the area of the base, you times that by the height of this thing. Uh-oh, I have two heights there. I know that's confusing, but we have to sort out which one is which, okay? We'll get to this in a sec. For a triangle, there's a base, there's the height of the triangle. If I want to know the area of that, that's 1/2 base of the triangle times height of the triangle. That's just this in this formula. Then I have to times it by the height of this guy, okay? So I know it's confusing, but that's what we have to work with, okay? Now, this one's nice. They're giving it to us in the right orientation, is a good word. What if this guy was on its side like a tent or a Toblerone bar, and they said, find the volume of this prism. Is this what we would use for the base? This bottom piece? Because now that's the bottom. Some of us say no. Good. Here's why. When I'm talking volume, I'm talking space inside it. Let's say this thing is a piece of cake. Okay? If I slice this thing like this, okay, and I dish it out between 1, 2, 3, 4, 5, 6 people, do you all get the same volume of cake for each piece? Yeah. Okay? What happens if I slice this guy? I'm going to take that one, I'm going to slice it again, and this one I've only sliced into 4 pieces. Okay, which piece would you like? The bottom piece or the top piece? All right. Yeah. Do we see how the volume isn't consistent as we go up in height? Okay. So if you're given a shape and it's like that, you have to know that has to be the base of this shape. Okay? It has to be this triangle here, not that bottom one. Okay? So when we're talking about the height of this thing, that's this dimension here. Hey, that's not height, that's length. Call it whatever you want, okay? Call it Virginia. But this is the dimension you have to use, okay? A little confusing. We are not talking with cylinders. We're doing that either tomorrow or the next day, but think of it like this, right? Everything you got in grade 9, maybe it was in that shape. How do you get the volume of that, right? The base, which was pi r squared, times the height. That's the same thing. Well, did you ever see one on its side? Okay. Well, that was still the base, wasn't it? And this was still the height, right? You didn't try to find this base. Well, what is that? That's just a line. There's no area there at all, right? It's lying on its side, okay? So don't get confused. This piece has to be the base. Okay, if we're giving you a Toblerone bar and saying calculate the volume, okay, of that thing, you have to think visually put it on its end, or you have to know that's the base. Okay? Volume's usually easier than surface area. Surface area is the hard one. Okay? All it says, look on your formula sheet for the formula. For general right prism, what does it say? The sum of all the areas. And that's kind of when I asked, what is surface area? That's kind of the answer Alicia gave us, isn't it? It's like the areas of all the sides. Okay? You got to add them all up. For a rectangular prism, there's a bit of a formula there. Let's quickly review that. Okay? How do I find the surface area of this shape? Okay? Volume's the easy one. That's length times width times height. Do you remember the word a net? That's when you slice this thing up and make a 3D image, a 2D image. If you're going to make a net of this thing, okay, it would look like this. Okay, and on the ends, it doesn't matter where you put them, you got to put them somewhere. Does everybody agree? If I sliced this guy along all its seams and flattened it out into a 2D image, that's what it would look like? Yeah. That's called a net. Okay? Here is a box. If I slice that thing and flatten it out, picture is worth 1,000 words, isn't it? That's what we get. How many flat surfaces are there? 1, 2, 3, 4, 5, 6 sides, right? There's 6 sides in a box. Okay? I have a top, I have a bottom. What do we know about the top and the bottom of a rectangular prism? They're the same side. Size. Okay, I have a left. I have a right side. That's 4. What do I know about the left and the right sides? They're the same. Lastly, I have a front and I have a back. What do I know about the front and the back? They're the same. Okay? So if that was 4, this dimension, doesn't matter if you call it the length or the width, that's 3. This one is the height. Let's call it 2. Some people call it the depth. Hey, if it's a swimming pool, sure, makes sense. Height, depth, same thing, right? Okay. I want the top piece. That's 4 times 3. Okay. But isn't that the same as the bottom piece? So I'm going to double that one. Okay. That's the top and the bottom areas. Okay. Let's look at the left and the right. What are the dimensions of this guy? That's 3 times 2. Everybody okay? Yeah. And that's the same as the left, isn't it? Okay, there's 2, there's 4 pieces. Remember, I need 6 pieces here. Okay, what's left? The front and the back. Look at that one. What's the dimension of the front? 4 by, that's 2 there, that's also 2, that's also 2, right? 4 by 2. That's this piece here. Okay, so I have 4 by 2, but remember the front is the same as the back. There's my 6 pieces. Okay? I need to add all these together. I want the total surface area. I want the area of that one, which is the same as that. This one, same as that. And this one, same as that. Add them all together. That's the total surface area, whatever the number is. Look on your formula sheet. Is there a little formula there? Yeah. What does it say? Surface area is 2 times bracket width times height plus length times width plus length times height. if I expand this thing out, what do I get? I get 2 times that plus 2 times that plus 2 times that. Okay? Is this the same as this? It is. Okay? So it doesn't matter which way you do it. And if you got to do one piece at a time, add up all 6 pieces, you'll get the same answer too. Okay? You can use the formula, or you can use this strategy, draw a net. Okay? Whatever makes sense to you, that's the way you're going to want to do it. Okay? I'm not spending too much time on this because, like I say, this book doesn't even have an example to do this. They expect grade 10s to know this. Okay? Okay? Thanks for your input. All right. So like I say, if you're having trouble with that, guys, I'm here. If you got a question, come in and ask. But that's all I'm going to say about that. Okay, let's go right to an example. There's a chunk of cheese. I want the area of the base of this prism. Okay? This question's going to go easy on us. We're going to guide us, it's going to guide us through the process. Eventually I want the volume, but first let's just get the area of the base. Is that this piece on the bottom? Are we okay with that? Think to yourself, is it consistent as I slice this thing up? Yes, it is. Okay, so that's the base. What kind of a shape is that? Let's draw it. Yeah, that's a triangle. I need to know the area of this triangle. What's the formula for area of a triangle? And by the way, that's in your formula sheet. Look under square-based pyramid. There it is. Area of a triangle is 1/2 base times side, but they mean the height. It's also somewhere else, I believe. Okay, but I think most of us have that memorized. Area is 1/2 times base times height for a triangle. Yeah, it is somewhere else. Yeah, okay. So it's on your formula sheet, even if you forget it. I'm under huge stress. I got the test. Oh my God, I can't remember it. It's on there somewhere, okay? I need to know the base of the triangle, which is 10, right? What else do I know about the triangle? I know this length is 13. So my area is 1/2 times 10 times... Is that the height of the triangle? It's not. That's not the height of the triangle. Okay, that's the height of a triangle. It always has to make a right angle with the base. Is that given in here? Is that dimension given? Oh, that sucks. How do I find it? Oh, Pythagoras, yes. Pythagoras. This is a right angle triangle. C squared is A squared plus B squared. Okay, we've already seen this in this course. If you didn't know it then, you really need to know it now. Okay, C is always the hypotenuse. That's the longest side. It's always the side opposite the right angle. Okay, I want to know, let's call it A. I want to know what A is. Okay, so A squared is minus C to both sides, C squared, okay? A squared is C squared minus B squared. I didn't do that right. Minus B squared to both sides. That's better. Okay? I want to solve it for one of the legs. So let's write it like that first. Okay? So A squared is, C is 13, so B is 10. 13 squared is 169. 10 squared is 100. That's what A squared is. And what's 169 minus 100? 69. Okay, so that's A squared. How do I know what A is? You know what, guys? I made a mistake. This length is 10. I just want this. How long is this? My apologies. So, a squared, let's try again, is 13 squared minus 5 squared. I know, he should know better, shouldn't he? Like, he gets paid for this stuff. Like, what's going on? Okay, because this one I know works nicely, and that one wasn't going to work nicely, because 69 is not a perfect square. 169 minus 25. A squared is, that's nicer, 144. How do I find out what A is? What's the square root of A squared? A. Whatever you do to one side, do to the other side. A is 12. That's my height. Okay? Height is 12. So the area of the base, finally, 1/2 base times height, 1/2 times 10 times 12. Now, how do you guys do that? Do you go 10 times 12, 120, divided by 2 is 60? Or do we do it the easy way and go 2 into 10 is 5, 5 times 12 is 60? Doesn't matter, as long as you get the right answer. Do I have units here? Centimeters, area is always in centimeters squared, right? Square units. Okay? That's just part A. Determine the volume of the prism. Okay. We're going to get a lot of shapes here. All sorts of shapes. The process is exactly the same. Look up what you're trying to find. What shape is this? Then determine if you want surface area or volume. Then find the formula. Okay? This is, there's nothing special for a triangular prism, so that's under general right prism. What's the formula for volume? We already wrote this. Volume is area base times height. Okay? Well, I just found the area of the base. I did that in part A. So the volume is 60. I'm just going to leave the units. What's the height of this thing? It's given. Okay? The height is from the base to the top. That's 6. So the volume is 6 times 6 is 36. Add a 0. What's the units for volume? Cubed. Yeah. Centimeters cubed. Now that we know exponents, think of it this way. I have 60 centimeters squared times 6 centimeters. Just look at the numbers. I am multiplying with the same base. What do I do with my exponents? Yeah, what's 2 and 1? Yeah, okay, that's another way to think about it. Okay, surface area is always harder than volume. Oh, that is volume. I'm still up there. So, surface area. Okay, sometimes a net will help you. Okay, how many sides does this thing have? Because our formula says we need to add up the areas of all the faces. How many sides does this have? How many faces are there? Some of us say 5. Picture is worth 1,000 words. If I split that guy up and make a net, I have 1, 2, 3, 4, 5 pieces. Some of these pieces are the same size, right? That's something to think about. That might be helpful, okay? If I slice this start with this chunk right here. There it is. Fold down this triangle, and it goes like that. Fold out the other side, it goes like that. And then I have these pieces on the end folded out, but those are rectangles. Okay? Some people like to visualize. If you want to do a net, then do it. If that's going to help you get the mark, do it. Okay? Because it's kind of hard to see what you need to do looking at this mess. Okay? So what do I have? I have the bottom piece. I need to add this piece. Is that the same as another piece? That's the same as that one. So I have two of those. Okay. Let me move this guy. Right. Okay. And finally, this piece. Is that the same as another piece? Yeah. This piece is the same as this piece on that side. Okay. That's this one. That's the same as that one. Each one is 13 by 6. Okay? 13 by 6. I have two of those. 13 by 6. This first piece, that was here. That's what? 10 by 6. Okay? And I have two triangles. Did I already figure out the area of the triangle?
Yeah.
Yes, I did. Right? Because that's the area of the base. I have one on the bottom. I have one on the top. Here's my 5 pieces. 1, 2, 3, 4, 5. I just need to add all these up. And I'm done. Okay? This one is 60. I have two of those, which were 60. And I have two of these, which are 13 by 6. Okay? Which is 78 times 2. These are 156. That's 120. That's 60. So my total surface area, add them all up, 336. What are the units for surface area? Square centimeters. Okay? Yeah. Piece of cake, right? They're tricky, all right? Volume's usually easier than surface area, unless you got to do Pythagoras. Okay? That's as hard as it's going to get. I'm going to give you a question like that in about 5 minutes. Serious. Yeah, totally. All right. There's a couple of conversions you may need to do. Okay, I don't think those are on our formula sheet, which means they probably won't get asked in the government exam. But did everybody know that a cubic centimeter is a milliliter? It's also known as a cc, right? If someone's sticking an injection in you, 10 cc's, that's 10 cubic centimeters. Or 10 milliliters, it's all the same volume. Okay? Cylinders, we'll do tomorrow. What do we want to do now? No, you can't sleep. Okay. Page 169. A commercial garbage bin in the shape of a cuba, special rectangular prism. If it helps, guys, draw it. Okay? Picture is worth 1,000 words. It has a volume of 60.24 cubic meters, or meters cubed. What are the dimensions? Hey, that's not fair. You have to give us the dimensions, and we calculate the volume. That's how the formula looks. What's the formula for this shape? base area times height. Yes, it's length times width times height. Same thing. But I want to be consistent with what's on our formula sheet. Huh. Ah, but it's a cube. What do I know about base area and height dimensions? They're all the same. What's your favorite letter? Leon? Sometime today. Don't listen to her. What's your favorite letter? Okay, W. Oh, all right. You like X? Use X. You like L? Use L. The book uses S for side. Kind of makes sense. Who cares? The volume is, what's the base area? W times W. What's the height? Oh, look, another W. Okay? The volume is W times W times W. When you multiply with the same base, what do you do with your exponents? What's 1 and 1 and 1? The volume is W cubed. I got to solve this thing for W. 60.24 is the volume. What's W? If only I knew a way to do that. What times what times what is going to be 60.24? Cubed root. God, you guys are brilliant. If I take the cubed root of W cubed, what do I have? W, right? Remember, the bottom part is the radical part. The top part is the exponent part. What's 3 divided by 3? W to the 1 or just W. Whatever you do to one side, you have to do to the other side. Okay? What's the cubed root of 60.24? Cubed root, 60. Whoop, missed my 0. 3.92. That's the dimension. Guess what 3.92 times 3.92 times 3.92 will give you? 60.24. Yeah. Okay. So W is 3.92. Did I answer the question? Centimeters. Did I still answer the question? To the nearest centimeter. Always read the question. Might be tenths, might be hundredths. What's that to the nearest centimeter? Yeah, 4 centimeters. Okay? Fun stuff. Okay, centimeter. You know what? Let's change it. I don't want to do all that. Meter, okay? It was in meters, wasn't it? Yeah, it does say centimeter. Let's just make it meters, okay? And remember, if that was 64, I hope you wouldn't have to do any thinking at all, right? What times what is 64? 4. But we rounded it, remember? Right? So that's kind of close, okay? Okay. Last one. Toblerone. You guys seen one of these before? I what? Really? Did I give you guys some Toblerone in grade 8?
I think we need some
Skittles too. Well, you ain't getting any this year. Okay. I still have the box. It's empty. Don't worry. There you go. Because that's the shape we're trying to talk about. All right, that's a bad Toblerone bar. Could be a tent. Same question, right? Okay. It's in the shape of a triangular prism. The triangle faces have a base of 3.7 centimeters. What are they talking about? Like I say, there's 2 base words, there's 2 height words. Okay, you got to be clear what they're talking about. The triangular face, that's it, has a base of 3.7 centimeters and a height of 3.2. Okay? They're not talking about the height or length of the Toblerone bar. That has to do with just the base. Everybody okay with that? Because it's like a word problem, isn't it? You got to figure out where to put the numbers. Well, that's good. Looks like we don't have to do Pythagoras if we want to know the area of this piece. Okay? If the space in the empty box, hey, that kind of sounds like volume, is that, okay, determine the length of the box. What shape are we talking about? Triangular prism. Do we want surface area or volume? Volume. Start there. What shape? What do they want? Surface area or volume? What's the formula? Look it up. Okay? General right prism, that's the triangular thing. The volume is area of the base times height. Okay? Well, let's just use H because that's what they have on our formula sheet. Okay? Yeah, same formula. I'm saying the same thing over and over, but we're going to be having pyramids and spheres and cylinders. Same process every time. Look up the shape. Are they asking for volume or surface area? Get the formula. Okay? Now, what are we trying to find? Length of the box. What is that in our formula? Does it have an L for length? This is what they want. It doesn't say length, does it? It says height. This is the length of the Toblerone bar. Remember, this is the height for volume in the formula. Is that confusing? Yeah. Okay, but we got to come to grips with it. Right? What do I know? I know the volume is 123.7. I'm trying to find the height. I can only do this if I know the area of the base. Can I find the area of the base? Yes. That shape is a triangle. The formula is 1/2 base, there's another base, times height. Okay? If you put that in your calculator, 3.7 times 3.2 divided by 2, it's one way to do it. All the numbers on the top multiply. All the numbers on the bottom divide. Okay, we get what? 5.92. That's the area of the base. Let's put it right here. Okay? The only variable I have in this equation is h, the height, or the length. How do I solve that thing for h? Yeah, 5.92 times h. Always do the opposite operation to isolate for the variable. What's the opposite of times? Divide. I'm running out of room. Okay, that divided by that, put it on your calculator. H, or the length of the Toblerone bar, is 20.895 centimeters. Did I answer the question? Nearest tenth of a centimeter. Okay, what's this in tenths? Bailey? 20.9, yes. Okay, length 20.9 centimeters. Okay. Okay, tricky stuff, guys. Like always, don't put it off. Come in and ask me. 2, 6, 10, 12.